Hi everyone, thank you very much for listening to my presentation describing turkey primary wing feather growth, implications for biomarker measurement. My name is Emily Leishman. I'm a PhD candidate in the Department of Animal Biosciences here at the University of Guelph, and my thesis revolves around identifying novel health and welfare phenotypes for domestic turkey selection. But today I'm going to be talking about feathers. So feathers are becoming a really popular tool in bird physiology research. Feathers can be used in studies looking at stress axis activity, environmental contaminants, and even temperature stress, among other things. And feathers are becoming popular because they offer several advantages. Collecting feathers is relatively non-invasive, certainly less so than collecting something like a blood sample. Feathers offer a long-term and retrospective view of the biomarker you're interested in. And feathers can be stored really easily. So just in an envelope at room temperature, they don't require any fancy freezers or equipment to keep them stable. To give you an example of how this whole thing works, we can look at feather corticosterone. Corticosterone is a glucocorticoid hormone, which is involved in energy balance as well as the stress response. And corticosterone circulates in the blood. And feathers, as they grow, have a blood supply. So you can see here, this dark red portion leading up to the feather, that's what we call the blood quill, and it feeds the growing feather. And so these hormones circulate in the blood and inevitably circulate in the blood quill. And so as that feather grows, those hormones in the blood quill get deposited in the growing feather as it grows. And then when the feather is done growing, that blood supply will recede. And if you sample that feather, you are essentially left with a longitudinal record of circulating corticosterone for that period of feather growth. So you can see how this can be a really long-term measure because feathers grow over periods of days to weeks. So it's a lot more longitudinal than more acute measures, which is really, really cool. So why does it matter to look at feather growth and molting patterns? Well, bird feathers do not always grow at the same time. And this is important because, wing feathers don't necessarily grow at the same time as tail feathers, and even within feather groups, they don't always grow at the same time. And this is really key to understanding the results of studies and designing studies, just to make sure that you know when those hormones or biomarkers were actually deposited in the feather, just to provide some context to your results. And within a feather, or even between feathers, growth and growth rate is not always constant. And so this is really important for those studies who are taking whole feathers and they're actually dividing them into sections to look at temporal variation and how those hormones are deposited. So it's really important to have some sort of idea of how fast these feathers grow when you're dividing these feathers to make sure that you are representing the time periods that you think you are. And so overall, all of these things can influence how we interpret feather biomarkers and how we design studies to look at feather biomarkers. Now, the opportunity here is that few studies of feather biomarkers actually provide the feather growth information. And this is really important to getting some sort of context to the results. And in modern turkeys, feather growth patterns are not well described. There are a few accounts from the 1940s, but given the 80-odd years of genetic progress in turkey breeding, it's probably worth updating these accounts just to make sure that the patterns and growth rates hold true. So the objective of our study was to describe feather growth rate and molting pattern of domestic turkey primary feathers. And this is part of a much larger study, which is looking at feather corticosterone as a novel phenotype in domestic turkey selection. So it's really important for us to have that context to our results, just so we know, when these hormones were deposited in our studies. So we had 45 female turkeys that we raised from 1 to 20 weeks of age at the Arkell Research Station here at the University of Guelph. And the feathers that we're looking at, like I said, are the primary feathers, which are the outermost feathers of the wing. They're flight feathers. And these feathers are used a lot in biomarker research because they're really easily identifiable. You can count them, you can tell them apart. So for example, turkeys have 10, and you can count them from 1 to 10, going from proximal to distal. And so they're used a lot, and that's why we chose to focus on this particular group. The design of the study is relatively simple. We took manual measurements of the primary feather length and tracked their appearance, when they stopped growing, when they molted, at our research station. So we had one person essentially holding the turkey, one person measuring the feathers, and then the other person recording the data. And so we did this for our 45 birds, 10 feathers. We did that for our 20 weeks. And so effectively we have 9,000 measurements of turkey primary feathers. So it's one of the more comprehensive assessments of turkey primary feather growth. In terms of presenting our results, we did a descriptive analysis of the growth pattern and the feather length over time. We also use linear mixed models to determine if the average growth rate differs between our feathers. So to determine average growth rate, we took the final feather length and divided it by the total growing period to get an average across those 20 weeks for those feathers. And then we wanted to figure out if there were significant differences in the average growth rate between our feathers. So moving into the results, just to quickly take you through the molting pattern. So in figure A in the top left, this is a wing image of one of our birds at day 1. So right out of hatch. And what you can see from this picture is that at day 1, they have primary feathers 1 to 6 present. So 7, 8, 9, 10 are not there yet, but already right out of the gate, they have those first 6 primary feathers. And then the other images, B, C, and D at week 7, 12, and 20 respectively, you'll notice one thing in common between these 3 pictures, and it's that one feather is a lot shorter than all the others. And this is just to illustrate what is called a descending molting pattern. And so what happens is that when primary feather 1, it grows, and when it's ready to molt, it will molt off. And then the new primary one will start to regrow in its place. And when that new primary one is almost at its final length, primary 2 will molt off and begin to regrow. And then when the new primary 2 is almost at its full length, primary 3 will molt off, and so on and so forth. And so what happens is you only have one feather molting off at the same time. And this holds true in our modern turkeys today, but it is a conserved strategy because these are really important flight feathers. So birds don't want all of these feathers molting off at the same time, because if they ever had to use their wings, they wouldn't be able to very well. And so these feathers molt off one at a time, so their wing ability is not significantly impaired. And while this isn't probably the most important feature for modern domestic turkeys today, who don't get the opportunity to use their wings as much as wild turkeys, it's really cool to see that, you know, even after 80 years of progress, we still see this really conserved molting pattern. And just to show you that pattern graphically, so bear with me while I orient you here. On the x-axis, we have the time in weeks, and on the y-axis, we have our 10 primary feathers. So those orange bars represent the weeks when those feathers were growing. So if we look at the left-hand side of those orange bars, what you'll notice, like you saw in the last slide, primary feathers 1 to 6 were all present at week 1. So day 1, they were there. And then the next week, primary 7 appeared. The week after that, 8 and 9, and then the week after that, primary 10. So although all the primary feathers weren't there on day 1, they did gradually fill in within the next 4 weeks or so. And then the other part, so if we look now at the right-hand side of those orange bars, this is when the feathers stopped growing and then molted off in that sort of sequential manner. So you can see that primary feather 1 stopped growing and molted around week 5. And then the following week, primary 2 would molt off, the following week 3, following week 4, etc., etc. So it's almost this straight line. If you drew a line along the right-hand side of those orange bars, it really shows you that kind of typical descending molting pattern and just how all the feathers don't molt off at the same time. It is also worth mentioning that while we did observe feathers 9 and 10 stop growing, we didn't actually observe them to molt within the 20 weeks or so of our study. And now if we look at the results of our average growth rate. So we took the average growth rate of our primary feathers and compared them. And we did find that the average growth rate was significantly different between our 10 primary feathers. So this can be thought of in a few ways. You'll notice that the largest differences lie between feathers 7 and 8 and feather 10. So if you look at a wing, primary feathers 7 and 8 are some of the longest feathers on that wing, but they also molt off and regrow earlier. So they have a relatively shorter growing period, but they grow pretty long. Primary feather 10 it didn't molt in our study, although it did stop growing, but it's one of the shorter feathers on the wing. So it has a really long growing period, but doesn't grow very long. And so naturally, if you have to grow really big and have less time to do so, your average growth rate is probably going to be faster than a shorter feather with a longer growing period. So although we did see some significant statistical differences in the average growth rate of our feathers, there's probably a biological reason behind it, because it does sort of follow that pattern of the wing. And it's also worth mentioning that the biggest difference here, I think, is about 1 centimeter per week. So it's not drastically different. But overall, across the board with our feathers, the average growth rate of all 10 feathers across all the times was about 2.4 centimeters per week. So they grow in pretty fast. And now if we look at our growth pattern, so looking at how the length of that feather is changing over time to get a sense of how fast that feather is growing as it changes over time. And so what you have plotted here again is weeks on the x-axis and then feather length now on the y. And on this particular figure, we have the first 6 primary feathers because they all appear at the same time. And if you look at where those lines end, again, you can see that really cool descending molting pattern as they stop growing. But if we look at the shape of the line, one thing you'll notice across these feathers is that the slope is typically the highest soon after emergence. And then as the feathers reach their final length and stop growing, that growth rate will sort of taper off and reach a plateau, and then the feather will stop growing and it will molt. So it's not just a linear relationship between emergence and molt. Its growth rate isn't necessarily constant, but does appear to be really rapid and then slowly taper off. And this can actually be seen in the rest of the feathers too. So if I add primary 7 here, primary 8, primary 9, and primary 10. So although these lines stop and start at different periods on this graph, they still have a relatively similar pattern where the slope is usually fast and then it will taper off towards the end of the feather growth, which is really cool to see. So the main takeaway here is that it's not just a straight line in terms of the growth rate. So overall, the implications of our study is that turkey primary feathers grow at different times. So they don't all appear and molt off at the same time. And this is really important when you're not only designing studies, but also just in interpreting the results. So if you measure a biomarker in turkey primary feather 1, we now have an idea of when that growing period is, which is when those biomarkers would be deposited. And then the growth rate, it is different between the feathers. Again, there's probably a biological reason for it, and perhaps it's not practically different, but it is statistically different. And the growth rate is not constant over the growing period. So this is really important if we ever needed to design a study where we are cutting feathers into sections. We're going to be able to do that more accurately now because we have an idea of how that growth rate, how that length changes over time. And so all of these above things can influence how biomarkers are deposited in feathers, and they can also influence how we interpret the data. But now we have a better idea of how this works, and it's going to provide a lot of important context for our future work in this area. But overall, consistency is key. So one of the more important things is to make sure when you're selecting feathers that you are consistent and you're choosing the same feathers. And you're considering things like growth rate as well if you are getting into more complex studies where things are being divided into sections and so on and so forth. And if you do want to know more about this study, it is published in the Journal of Animal Science if you want some more details. And with that, I just want to acknowledge all of the university departments and funding sources for supporting this work, and thank all of you for listening, and I'd be happy to take any questions. Thanks.